welcome to video number 2 on our new topic, arrays. From Mr. Dovovich's last video, we learned about how to make arrays and how to access elements within an array. Today we're going to talk a little bit more specifically about how we can access multiple elements within an array and check for certain types of conditions. The first thing that we want to try to do is be able to do some kind of action to every element that exists within an array. The way that we want to do this is through the use of a for loop. So let's say we want to add 2 to each value in nums. In order to do this, we're going to use a for loop, and I'm going to create some variable that will be the location. This location variable is going to be accessing the index within our array. We've done this similarly with ArrayList before. And to continue with this idea, I'm going to create this variable to be location starting at 0 and let it go up until 4, because there are 4 things that exist inside of this array. So we'll start at index 0. We've got 0, 1, 2, and 3, but we can stop when we hit 4. We'll want to increment our location variable by 1. And then all we really want to do is access each element, nums, not num, access each element that exists within inside of our array. And we're going to just change its value, nums. We got it, Miss Glenn, don't worry. And we're going to add 1 to it. So we can do that just like this, and then we'll want to print out that array. Remember, we'll have to use that idea of arrays.toString from last time, and we'll use nums to do that. Import the right things, and this should print out nicely for us. Let's try it. I've now taken my original array that was 1, 3, 4, 5. I've added 1 to each element, so now it reads 2, 4, 5, 6. Now, when I did this, I knew the value, or I knew the length that existed for nums, so I could set this condition to be a specific number. However, a lot of times when we're dealing with our arrays, we might be testing multiple arrays where we don't have necessarily the same length, or we might be testing arrays that we don't actually get to see at all, and in which case we won't know their length. So in order to circumvent that kind of a problem, we'll use that keyword length. It's possible that you've seen this in our array1 practice. If not, using this .length command will tell you and return the value that is the length of the array that is given. So in this case, that would be equal to 4 for nums, and it works the same, but it is then a little bit more built in. So we don't have to know as much information about nums. Now, that's great. We can now access each of the elements that exist within inside of nums, but we likely want to do more than just change the values that exist inside of there. Let's say instead we want to now see if there are any, I'm going to call them addition pairs. And what I mean by that is where the next value is 1 more than the previous. So an example of this would be in a situation that I've got 0 and then 1 next to each other in an array. I'm going to use curly braces here, sorry. 0 and then followed by a 1. Or 7 followed by an 8, anything of those situations. So in order to do this, I want to loop through my array in the same way that I have before. So I'm going to set up another for loop similarly to how I've done before. This time, the check that I'm going to be doing is a little bit more complicated than in the previous. This time, what I want to see is I want to know if the value that's at the location I'm at is equal to the value at the next location. Why did it do that? Oop, the value at the next location which means I really want location plus 1. I don't want to know if they're equal to each other. In this way, I want to know if they're equal to each other, but with a difference of 1. In this case, 0 and 1. Well, if I take this value that's here at 1, I subtract that addition of 1 from it, they should be equal to one another. Or in the same way, I take 0, I can add 1 to it, and it'll get me that next value. What I really want to see is if the value at the current location that I'm talking about plus 1 is equal to the next one. Those would be the types of addition pairs that we would be looking for. So if that's true, for right now, all I'm going to do is print out the location at which I find one of those values. Oops, add that plus in there. I'll just print out the location at which I find one of those values. So, based on what we know about nums, we think that some of these might exist. Let's try it. So we did. We found 2 of them. We found one at location 1, so talking about this position of the 3, and we found another at location 2, talking about at this position of the 4. Great. However, we also see this exception that is array index out of bounds exception at 4. Index is then referring to the position, or what we've been calling the location of each of these values. Index out of bounds exception is like the array cardinal sin kind of an exception or error to receive. What this means is you're trying to reference an index that doesn't exist. You are trying to reference the index 4. Well, 0, 1, 2, 3 doesn't exist. There is no index that exists here at 4. So it told us exactly which thing we are doing wrong. The issue is here, when I try to go through and loop through this list, I'm doing a little bit too much work. Let's try to debug a little bit by printing out the location each time I loop through and try to find these addition pairs. So I can do it. I started 0, didn't find anything. Go to 1, found something. Go to 2, found something. And then when I'm at 3 is when I seem to hit this error. So let's talk through it. Okay, location is equal to 3. So now if nums 3, meaning that value right there, plus 1 is equal to nums of 3 plus 1, meaning 4. Nums 4, oh, right there, doesn't exist. That's our problem. So what that means is I'm checking this condition for this last element in my array, but it's really impossible for that last element in the array to have an addition pair because there's nothing that comes after it. So in order to fix that issue, I really want to go back and think about the condition of the bounding of my for loop. Rather than having additional checks inside of here, I can just stop my for loop a little bit early. I know that 1 possibly has a pair, 3 possibly has a pair, 4 possibly has a pair, but 5 definitely does not have a pair. So I can stop my for loop 1 shy of the end of that array because 5 doesn't have anything that follows it and can't have one of those addition pairs. So with that change to our for loop, let's run it again and see if that fixes our issue. And it does. Great. So similarly to trying to find addition pairs, I'm going to use the longer list this time, but now using our array longer, we're going to look for addition triples. And what I mean by that are things like 0, 1, 2, where each element is 1 bigger than the previous. So similarly, I'm going to loop through. This time I'll use location to talk about longer. We'll use the longer word. And we learned from last time that we want to stop our location short of the end. So let's think about where we might actually see triples appear in this array longer. 1 has 2 things that follow it, so it absolutely can have a triple. 2 can have a triple. This next one can have a triple. 2 can have a triple. 3 can have a triple. As soon as I reach here, however, this value right here only has 1 element after it. So it is impossible for this value to have a triple. Similarly, it's impossible for that value here at the last final 2 to have a triple. So really, even though the length of this array longer is 1, 2, 3, 4, 5, 6, 7, I don't need to check 7 cases. I only need to check the first 1, 2, 3, 4, 5, because that's where my triples end. So I don't want to check all 7 locations. Ooh, longer. I actually want to check the length of the list, but back it up by 2, because triples can't happen at those last 2 indices. And then again, we will add to our location plus plus. Now there are many ways inside of here that we can do this double check to see how we can find addition triples. If you want, pause the video at this moment, try to think through yourself what logic you would use. There are many different ways that we can do this. Okay, so the way that I'm going to think about this is I'm going to use similar logic as I did from the previous when we were looking for addition pairs. And what I'm going to do is I'm going to look at the location that I'm currently at. I'm going to add 1 to it and see if that puts me at equal to, longer, the next indice. Now these two statements look really similar to each other. The grouping symbols are important. So if that's the case, that means we found one of those addition pairs, but we want more than just the pair. We want the triple. So if we're looking for the triple, what that really means is we also want to see, okay, we found a pair. That's for sure the case. Then the relationship that exists between that first number and that third number in the triple is that they are now a difference of 2 away from one another. So that's what I want to check for my second. And if both of those things are there, I would want to print out. Oh, come on. Found a triple at location, and I'll print out that location again. All right, so based on what we know exists for longer, we think that we're going to find one. It should happen right there. So let's test it out and see what we find. Found a triple at location 2, which is that one that exists right there. Perfect.